We've learned about different IV solutions, uses of IVs, IV equipment, insertion sites, and about the IV insertion process. But to complete this series, we've yet to look at how to calculate drip rates once we have an IV in place. These are the learning objectives we will cover in this video. Most likely, you are not going to work in a place where you have access to an IV pump, which means that you will need to calculate drip rates in order to give a specific amount of fluid over a specific time frame. If you have an IV pump and know how much you want to give per hour, you simply plug in the amount and hit start, and it will do the rest. Calculating and adjusting drip rates manually is a little more complicated, but not too hard to do. Before we jump into looking at how to calculate flow rates and drip rates, I want to take a moment to talk about mLs, milliliters, and cc's, cubic centimeters. Just as a reminder, most IV bags are 1 liter, which equals 1,000 milliliters. When it comes to solutions, 1 milliliter is equal to 1 cc. The two are synonymous and may be used interchangeably. It is easy to become confused if you don't realize this, and throughout this video you may hear both used. The amount of solution, milliliters, that we want to give over an hour is called a flow rate. To figure out a flow rate, we just have to take the volume we want to infuse, in milliliters, and divide it by the hours we want it to be infused over. For example, if we want to give Bridget 1 liter over the next 10 hours, we'd take 1,000 milliliters, divide it by 10 hours, and our flow rate would be 100 milliliters per hour. If instead of wanting to give it over 10 hours, we wanted to give it over 4 hours, 1,000 milliliters divided by 4 hours would equal 250 milliliters an hour. Pretty simple. Having a flow rate is great, but it is general and doesn't tell us how fast or how slow we need to adjust the rate of drops falling in the drip chamber of the tubing. To do this, we need to figure out how many drips we want to give in a minute, our drip rate. Remember, GTT is the acronym used for drips. The formula for figuring out a drip rate is volume to be infused in milliliters times the drip factor of the tubing divided by the time it is to be infused over in minutes. Let's go through a few examples. Trisha is exhausted from a long labor and has become dehydrated, but she is able to sip on a little juice and eat some fruit. We decided to start an IV of lactated ringers with macrodrip tubing, 10 drips per ml, and to give a bolus of 300 cc's. After the 300 cc's are in, we slow the rate down and decide to give her 150 cc's an hour. What will we have to adjust our drip rate to in order to accomplish this? We would take our volume, 150 milliliters, multiply it by the drip factor of our tubing, 10, and divide it by 60 minutes, which would give us a drip rate of 25 drips a minute. So how do we regulate this? It helps if we narrow it down to how many drips a second. If we take our 25 drips and divide it by 60 seconds, we get 0.4 drips a second. Round that a little bit and we get 0.5 drips a second, half a drip a second. So that would come to approximately 1 drip every 2 seconds. Watching a clock, this is what we would set our drip rate to. Our patient Anita just hemorrhaged 650 cc's with her birth and is looking pale. We decide to start an IV of normal saline using macrodrip tubing, 10 drips per ml, and we want to give 500 cc's over the next half hour. What would our drip rate have to be to do this? We would take our volume, 500 milliliters, multiply it by the drip factor of our tubing, which is 10, and divide it by 30 minutes. This would give us 166.6 or 167 drips per minute. In order to figure out how many drips per second to give, we would divide this by 60 seconds, and we get 2.78. Round it up a little and we get 3 drips a second. Giselle hemorrhaged 1,200 cc's at her birth. Over the past hour, we gave her 1 liter of lactated Ringers, and now we have decided to hang and give her a second liter over the next 2 hours. We are using 15 drips per ml tubing. What is the flow rate we would want to give to accomplish this? Remembering our formula for determining a flow rate, we would take our volume, 1,000 milliliters, and divide it by 2 hours. Our flow rate would come out to 500 milliliters per hour. What drip rate would we need to set in order to administer 500 milliliters an hour? We'd take our volume to be infused, 500, multiply it by 15, the drip factor of our tubing, and divide it by 60 minutes. Our drip rate would be 125 drips a minute. Divide that by 60 seconds, and we get 2.08 drips a second. Round it down, and we'd want to set our rate to 2 drips a second. One last example. Most likely, you will not be doing Pitocin inductions as a midwife practicing in the United States. But let's say you decide to volunteer for a summer at a small birthing clinic in a low-resource country. The midwives here have a protocol for doing Pitocin inductions on post-dates women. Generally, regulation of the IV solution for Pitocin inductions should be done through an IV pump, as it needs to be precise, and even slight changes to the drip rate may have significant effects on maternal and fetal well-being. However, IV pumps simply are not available at this clinic, so we are doing this manually with an IV setup using microdrip tubing, 60 drips per ml, for the greatest control. You are asked to increase the Pitocin drip for Sana to 15 milliliters per hour. What would your drip rate be? Our volume to be infused would be 15 mLs, multiplied by 60, the drip factor of our tubing, and divided by 60 minutes. We would get a drip rate of 15 drips a minute. 15 drips divided by 60 seconds equals 0.25 drips a second, 1/4 of a drip a second. So giving her 1 drip every 4 seconds would equal 15 drips per minute. Just to show you, if our Pitocin drip had been set up using macrodrip tubing, 10 drips per ml, our drip rate would come out to 2.5 drips per minute, or 1 drip every 24 seconds. There is absolutely no way that you could regulate a constant drip at this rate without an IV pump, so you can see where microdrip tubing becomes necessary for slow rates. Once we've adjusted our flow rate, there are a number of factors that can affect or change it. Maybe our patient moves or bends her arm a different direction. This may result in the rate either increasing or decreasing. Maybe she rolls over and the tubing becomes pinched or bent, or blood backs up in it and it becomes clogged, stopping the drip entirely. Maybe visitors come in and someone decides the clamp is fun to play with. The height of the IV bottle affects the flow rate. So if we set the rate for a patient who is laying down, and after a while she sits up, the flow rate may be affected by it. The point I'm getting at is that just setting a drip rate once doesn't ensure it will stay the same. Multiple factors, as we've just looked at, can affect or change it. So make sure that you check on it often to ensure it is still running at the desired rate or to readjust it if it is not. This concludes this video series on IV therapy.